So question 6, you've got to write the decimal number 657 using various um, bases essentially. So I'm going to start with Egyptian. Um, and so 957, this means we have, if I'm going to write it in decimal to begin with, that means I've got 9 times 10 to the second plus 5 times 10 to the first plus 7 times 10 to the 0. In other words, this is 9 times 100 plus 5 times 10 plus 7 times 1, 957. So in Egyptian, the Egyptian symbol for 100 is the scroll. So for question A, what I'm going to have is there's going to be 9 scrolls. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then we have 5 groups of 10. So we have 5 heel bones. 1, 2, 3, 4, 5. And then we have 7 groups of 1. So 7 strokes. 1, 2, 3, 4, 5, 6, 7. That's the number 957 written in Egyptian. So the number 957 in Roman numerals, I'll do that next. So 900, well 900 is 100 less than 1,000. So here's the Roman symbol for 1,000, and we are looking at the number 900, which is 100 less than 1,000. So I'm going to put a C in front of the M. Next, what I'm going to do is I'm going to look at the number 50. Rather than put 5 X's, I'll put the symbol L, which represents 50. And then the number 7 will be the Roman number V, followed by two ones. So that is the number 957 written in Roman numerals. So for writing the number 957 in Mayan, what I'm going to do is I'm going to establish the pattern of numbers that I need to divide into the number 957. And I've done that on the left side here. So what I'm going to do is I'm going to see how many groups of, well, in this case, 360 fit into the number 957. Because what I'm looking at is the number 7,200, which is 20 times 18 times 20, is way too big. It's bigger than 957. So I'm going to see how many groups of the number 360 fit into the number 957. Well, it turns out that 360 fits into 957 two times. 2 times 360 is 720. I subtract that to get a remainder of 237. So this means that the number 360, which is 18 times 20, fits into the number 957 two times. So there's 2 groups of 360. Now I'm going to see how many groups of 20 fit into the number 237. So I'm going to go 20 into 237. Well, 20 fits into 237 11 times. 11 times 20 is 220. I subtract, and I get 17. What this means is that I have 11 groups of 20 in the number 957. Now, I've got 17 as my remainder. Those are my units. I've got 17 units. So, to indicate this in Mayan, what I'm going to do is the number 17. Well, each bar is 5. So in Mayan, this will be 1, 2, 3 bars. That represents 15. 3 times 5 is 15 with 2 units. So that's 17 units. Then there's going to be a space, and I have 11 groups of 20. So I'm going to have 2 bars, each bar representing 5 with a single unit there. So that's 11 units of 20. And then I'm going to have 2 units of 360, or in other words, 2 groups of 360. Right, so the number 957 in Babylonian, what I'm going to do is I'm going to see how many groups of, in this case, 60 fit into the number 957. You see the number 3600, which represents 60 squared, is too big. So I'm going to start with the number 60. So here we go. So 60 into 957 goes 15 times. Oops. 15 times 60 is 900. Subtract, I have a remainder of 57. What this means is there are 15 groups of 60 in the number 957. So I've got 15 groups. So in Babylonian, I'm going to write that as a boomerang. And then 5 ones. 1, 2, 3, 4, 5. Okay. And so now I've got a remainder of 57. That means I have 57 ones. So I'm going to write 5 boomerangs and 7 ones. 1, 2, 3, 4, 5, and then 7 ones. 1, 2, 3, 4, 5, 6, 7. So there's the number 957 in Babylonian. So I'm going to write the number 957 in base 7. So I'm going to start off on the right-hand side of the page, and since the base is 7, I'm going to put a 7 there, and the exponent's going to be a 0. That's going to be my units. Then I'm going to move over to the left. I'm going to have 7 to the first, 7 squared, 7 cubed, 7 to the fourth, 7 to the fifth, and that'll probably do the job. And so now, what are these bases raised to the appropriate exponent represent? Anything to the 0 power is a 1. 7 to the first is 7 times 1, that's 7. 7 squared is 7 times 7, which is 49. 7 cubed is 343. 7 to the fourth is 2,401. Oh, but wait a minute, that's like way too big. I don't need that. I don't even need the 7 to the 5th. I'm going to stop and get rid of that. And in fact, the biggest number that will fit into 957 is going to be 7 cubed, or 343. So that's what I'm going to start with. So I'm going to go 343 dividing into 957. How many times does that go? Well, that actually goes 2 times. 2 times 343 is 686. If I subtract that, I've got a remainder of 271. So what that means is that I've got 2 groups of 343 in base 7. So this means that's really 2 times 7 to the third. Okay, so I got 2 groups of 7 to the third. So now what I'm going to do is I'm going to see how many groups of 7 squared are in there. So I'm going to go, okay, 49 is 7 squared. 49 into the remainder, which is 271. Well, how many times does that go? Well, that goes 5 times. 5 times 49 is 245. I subtract, I get 26. So this means I got 5 groups of 49 in the number 957. Or in other words, 5 groups of 7 squared. So I'm going to go 5 times 7. Oh, not 10. 7 squared. 5 times 7 squared Okay, so I got 5 groups of 7 squared. Now my remainder here so far is 26. Now I'm going to see how many groups of 7 I have in 26. So I'm going to go 7 goes into 26 3 times. 3 times 7 is 21. Subtract to get a 5. So I've got 3 groups of 7. So that's 3 times 7 to the first. And I got a remainder of 5. So that means that's 5 times 7 to the 0. So in base 7, this number becomes 2, 5, 3, 5 in base 7. Now, if you want to write it out more neatly, that would be 2, 5, 3, 5, base 7. Question 7. Calculate the following without converting to base 10. Well, what we need to do is, in A, for example, we're going to have 244 in base 5, and we're going to add 331 in base 5. Let me just clean up that 4. Now, before I do the addition, in base 5, I want to talk about adding in base 10. So, for example, say we have the number 8 plus 3 in base 10. So this is base 10 I'm talking about now. Okay, just as an example. In base 10, what I can do is I can rearrange the 3. So that is one group of 2 with 1 left over. So instead of writing 8 plus 3, I'm going to write this as 10 plus 1. And now I add it and I get 11. So what I did was I added 2 units to the 8 to promote it to the next place value up. So it would be 10, 1 followed by a 0. In a similar way, I could add 7 plus 8. So 7 plus 8. Well, if I rearrange this, I'm going to take 3 of the units from the 8 and bump them up to the 7. So I'm going to make that the same as 10 plus, well, I took 3 units away from the 8. That just leaves me 5 left. That's 10 plus 5 is, well, 15. I'm going to do a similar thing over here, except in base 5, the way the counting goes 0, 1, 2, 3, 4, 10, 11, 12, 13, 14, 20, 21, 22, etc. So when I'm adding in base 5, I'm going to think of this as just kind of like rearranging. So rather than adding 1 plus 4, I'm going to think of this as I'm going to take that 1, when I add it to the 4, that's going to push its place value up. So it becomes a 10. So 1 plus 4 becomes 10. I put a 0 there and I'm carrying the 1. Now what I'm going to have is, well, 1 plus 4 is, well, 10. 10 plus 3 becomes 13. So I'm going to carry that over. It's 1, 3 actually. So I'm going to bring another 1 over there. And now I've got 2 plus 3 in base 5 is the same as going 2 and adding 3 means that I've at the next place value up, which is 10. So that's 10 plus 1 is what would be 11. So I got 1, 1. So 244 base 5 plus 331 base 5 adds together to make 1130 base 5. So that was A. I'm going to do B. B, I'm taking 321 in base 8 and adding 777 in base 8. So 321 base 8. And I'm adding 777 in base 8. And so in base 8, the way the counting goes, it goes 0, 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 20, 21, etc. So if I'm adding 1 plus 7, that's taking me to the next place value. So I can think of this as going in base 8, 1 in base 8 plus 7 in base 8. What I'm doing is I'm rearranging this up to the next place value. So the 1 plus 7 units gives me 10 units. So here I am on the number line. There's 7, and I'm adding 1 to it. I end up at 10. So this becomes a 0, and I carry the 1. Now, okay, whoa, look at this. I've got 1 plus 2 plus 7. Now this is a base 8 system. So if I add 2 plus 7 in base 8, here's a little sidebar calculation. If I go 2 plus 7, this is in base 8, I can think of this as being rearranged as 1 plus 10 in base 8, which makes 1, 1 in base 8. Now, another way of looking at this would be then to go, okay, if that's the case, if 2 plus 7 in base 8 is the same as 1, 1, if I add another 1 to that, 11, if you like, plus 1 makes 12. Carry the 1. Another way to look at this is, if I look at this, this is the carryover from the previous addition, the 1. 7, the 7 plus 1 is like 10. And so you've got that 1 plus that 7 is 10. You add 2, you get 12. That's another way to look at it. Now, I've got a carry here because this was 1, 2 ultimately. And now the easiest way to look at this, I'm going to take that 1, I'm going to add the 1 to the 7 to make it a 10. So the 1 plus the 7 will make a 10, and I add the 3, that makes 13. So you end up with 1, 3, 2, 0 in base 8. I could have also rearranged this the way I was showing previously. So if I have really 1 plus 3 plus 7, what I'm going to do here is I'm going to rearrange this so that 3 plus 7, got the 1 there, I need to borrow one of these 3's. I'm going to add it to the 7 to make a 10, so that becomes a 2. And when I take one of these units away from the 3 and add it to the 7, that makes it a 10. If I do that, I can only have 2 units. I've converted the 3 to a 2 by borrowing one of its units and adding it to the 7 to make it 10. If I add it up, I get 13. That's one way of doing it to get this number, 1, 3. The other way of doing it is going, if I have 1, 3, and 7, and I'm adding them, you can do addition in any order. So I could say that this is really the same as 3, 1, and 7, because you can add in any order. If you add 1 to 7, you make a 10. So 1 plus 7, this, you can think of as a 10. 3 plus 10 is 13. And that's how I come up. Another way of coming up with that 13. Do whatever's easiest. The last question, I'll just get a clean slate here. So now we've got a subtraction. Well, first of all, I'll write out the base 7 number line. So here it is. It goes 1, 2, 3, 4, 5, 6, 1, 0, 1, 2, 1, 3, 1, 4, 1, 5, etc. What I'm going to look at now is the subtraction. So to start off with, I can take 3 away from 5. That's not a problem. That's just going to be a 2. That's going to be 7. And now I'm going to try to take the 6 away from the 4, which I can't do. So now I have to borrow. So what I'm going to do is I'm going to borrow from the 3. And what I'm borrowing from the 3 is, in fact, one group of 7 squared. But here's how the notation works. I'm going to borrow 1 unit from the 3 in base 7 and put it in the middle place value column. Now, when I'm doing the subtraction, what I borrowed here really is a group of 7 squared, or just think of it as a group of 7. So now what I've done is, instead of having in base 10, we'd have 10 plus 4 is 14. In base 7, this is 7 plus 4 is 11. I'm going to go 6 minus 11 is 5. Now we're done. So let's just take a look on the number line. Let's do it schematically here. So say here's the number 1, 4, 14. And I'm taking away 6 units. So I'm going to skip over here. 1, 2, 3, 4, 5, 6. There it is, 5. So if you take the 5 away from the 1, 4, sorry, if you take 6 away from the 1, 4, you get a 5. And that's how you get 57. Now, something I didn't talk about, or it's not in the practice test from Math 123 is, well, how do you write the number 345 base 7 in base 10? Let's just take a look at that, just as a bit of a refresher. So 345 base 7. So 3, 4, 5 base 7. So what does this mean? Well, this is, how many groups do we have? Well, this is 5 groups of 7 to the 0. This is 4 groups of 7 to the 1st. And this is 3 groups of 7 squared. So you add these things up, and you get a number in base 10. So let's just take a look. 3 times 7 squared, that's the same as 3 times 49, plus, well, 4 times 7 is 28, plus 5 times 1 is, well, 5. Okay, so 3 times 49, that's 147. So it's 147 plus 28 plus 5. 180 is equal to 180 in base 10. So 52 base 7 equals base 10. Just some added stuff for your information. All right, question 8. You have a chime clock and a cuckoo clock in the living room. The chime clock chimes every quarter of an hour, so every 15 minutes, while the cuckoo clock every half hour or every 30 minutes. Starting at 20 past 11 one morning, when the lecture ends, how many times would both clocks announce the time together by 3 in the afternoon that same day? Assume that the clocks are synchronized. Well, how do you do this? Well, the first time that they're both going to actually do anything is at 11:30. So here we go. We got the cuckoo clock. Yeah, let's do the cuckoo first. How do you spell cuckoo? Oh, look at that. Cuckoo clock. So it's going to chime every half hour. So it's going to chime at 11:30, 12 o'clock, 12:30, 1 o'clock, and then so on. Let's see. 1:30. Sorry about that. 2 o'clock. 2:30. Gotta hold this steady here. 2:30. 3 o'clock. Okay, so by 3 o'clock, the cuckoo clock will have chimed how many times? Well, let's count them. Cuckoo. 1, 2, 3, 4, 5, 6, 7, 8. The cuckoo clock would have chimed 8 times. How many times would the chime clock have chimed? Well, I'll change the color. Yeah, let's take a look at the chime clock. Okay, the chime clock, here we go. Well, the chime clock chimes every 15 minutes, so it would chime at 11:30 and 11:45 and 12, 12:15, 12:30, 12:45, 1 o'clock, 1:15, 1:30, 1:45, 2 o'clock, 2:15, 2:30, 2:45, 3 o'clock. But the only times they actually chime together are in the half hour, in fact. So at 11:30 they chime together, 12 o'clock they chime together, 12:30 they chime together, 1 o'clock they chime together, 1:30, 2 o'clock, 2:30, and 3 o'clock. A total of 8 times. They chime together 8 times. Announce the time. Okay. They announce the time together. 8 times. Because cuckoo clock, of course, goes cuckoo. And the chime clock just makes some sort of bell noise. But announce the time together 8 times. So every half hour, cuckoo. And every 15 minutes, ding. There you go. Okay, this is some modular math. So A, 54 congruent with some number, mod 3. Well, what's going on here? Well, let's take a look at A. So A, what you've got is you've got a clock. It goes 0, 1, 2. And so the hand starts off at 0, and then it rotates around. It goes from 0 to 1, then 1 to 2, and then back to 0. And so what you want to do is you want to find out how many times the hand goes around. And 54, what that means is we want to see if 54 goes evenly into the number of rotations of the hand. So what I'm going to do is I'm going to go, okay, well, 3 into 54. 3 goes into 5 one time. 1 times 3 is 3. Subtract to get a 2. Okay, bring down the 4. 3 goes into 24 8 times. 8 times 3 is 24. You can, of course, use a calculator. No remainder. Look at that. So that means that this little clock hand is going around 18 times. To account for the number 54, and there's no remainder. So this is 0 mod 3. Okay, let's look at B. Okay, well, now we got a different clock here. We've got a mod 8 clock. So what it's going to do is what we got? We got a 0, and we got 1, 2, 3, 4, 5, 6, 7. There's a clock hand there, starting off on 0. So we want to see how many revolutions there are, like in the number 157 in mod 8. So I'm going to do a division. I'm going to go 8 goes into 187. How many times? Well, if I take number 187, divide 8 into it, it goes like 23 times. Okay, 23. What's 23 times 8? 23 times 184. So what this means is in the mod 8 system, the module 8 system, the clock hand goes around 23 complete times, and you got a 3 remainder. So where's the clock point? The clock starts at 0, and you got a remainder of 3, so it goes 1, 2, 3. So when you're done, the clock hand is going to point on the 3. That's where it's going to end up. So that's your remainder, like 3 mod 8. So for C, 15 is congruent with 3 mod something. Well, way you can think of this is that 15 minus 3 is congruent with mod something. So 15 minus 3 is 12. 12 is congruent with mod 12. That's kind of the simplest thing it can be. Yeah, 12 is the solution here. If today is Wednesday, what day will it be in 400 days? Well, this is a mod 7 system, modulo 7. So what I'm going to do is I'm going to say, okay, well, how many times does 7 go into 400? Well, it goes, 57 times. 57 times 7, 399. So I got one remainder. So we're starting off on Wednesday. So we got Wednesday, Thursday, Friday, Saturday, ST, Sunday, Monday, Tuesday. So here's where the pointer is starting on the Wednesday, and it's going around 57 times. But it does 57 complete cycles, and then it goes a little bit more, and it goes 1 unit more. So when you're done, the pointer's pointing at Thursday. It does 57 complete cycles, and after 57 complete cycles, it's accounted for 399 days. There's one more day to go, so it ends up pointing at Thursday. So Thursday will be the day in 400 days. So Thursday will be the day in 400 days. Fill in the following table. Write any fractions in simplest form. Well, as we talked about in class, when you're going from percent to decimal, you divide by 100. So this is 0.63, and as a fraction, I could write this as 63 over 100. If I try to break 63 down by factoring it, factors are 7 and 9, and 100 is 10 and 1 and 5. So 63 is odd, so that's it. It's in the lowest terms. 120%. Divide that by 100, that's 1.20, which turns out as a fraction to be 120 over 100. So 120 over 100. Well, does that reduce? Yeah, sure it does. That'll reduce. It's both divisible by 2, so I could write that as 60 over 50. Still divisible by 2. I could write that as 30 over 25. And now, but 30 and 25 have some common factors. 30, you can say it's the same as 5 times 6. 25 is the same as 5 times 5. So what I'm going to do is I'm going to say that 30 over 25 is really the same as 6 times 5 over 5 times 5. Anything divided by itself is 1, so 6/5 would be the lowest terms there. Okay, 3/4. Well, 3 over 4. I want to make the 4 into 100. So what do I have to multiply 4 by to make it 100? Well, you take 100, divide 100 by 4. 100 divided by 4, use a calculator. 100 divided by 4 is 25. So that means I got to multiply the 4 by 25 to scale it up to 100. If I do that to the bottom, I do it to the top. So now up top, I have 3 times 25, which is 75. And 4 times 25 is 100, so that's 75 over 100. Writing this as a decimal, 75 over 100 is 0.75. Now, when you go from decimal to a percent, you multiply it by 100, so this is actually then 75%. 8/5. Okay, that's the lowest term. They're going to write 8/5 as a decimal. Well, that's the same as 16 over 10. Now, you can just use a calculator. And if you use a calculator, you get it as a decimal as 1.6. So you can go 8 divided by 5 in your calculator. That gives you 1.6. Or if you want to scale it up as a fraction, as I did here, it doesn't matter, you don't have to, but 8 over 5 is the same as 16 over 10. And so now writing that as a decimal, that turns out to be 1.6. Multiply 1.6 by 100 and you get 1%. Okay, the decimal is 0.6. Multiply the decimal by 100 and you get, well, what's 0.6 times 100? That's 60%. Now you're going the other way here. You got to go from a decimal to a fraction. So 0.6, that's the same as 6 over 10. 6 over 10 reduces to 3 over 5. 1.75, 1.75. Okay, I've got to convert from a decimal to a percentage, so you multiply by 100. 1.75 times 100 is 175%. Making it a fraction, 1.75. Notice there's 2 decimal places there. This becomes 175 over 100. Now, turns out, if you think of terms of money, like there's 25-cent pieces or quarters. So I'm going to go 175 and see how many times 25 fits in there. 25 fits into 175. Use your calculator. It goes about 7 times. 100, how many times does 25 fit into 100? Well, 25 fits into 100 4 times. So I'm going to rewrite this. I'm going to say 175 is the same as 7 times 25. I'm going to say 100 is the same as 4 times 25. Anything divided by itself is 1. So this is the 7/4. Well, that's it. Good luck on your test.